To understand something, you need to have a motivation. You have to have a curiosity. So you got to be curious about something. So this is why I don't set a standard project that is interesting to me. I let everyone go in a different direction. And because of that, that drives your interest in understanding the board. And some people may want to build a product at the end of it. They have imagination to do that. Some people have always been interested in building a toy that they've always wanted to build, or something like that. So with that motivation, your curiosity really drives your interest in understanding the complexity of this board. Because without a subject, the board is just, a board with electrical components on it. So you need to have that subject to sort of go and explore it. My name's Andrew Sloss, and I teach the Embedded and Real-Time Systems course on the PMP program. You can sort of see, as you grow bits of data, where your different cache lines live, right? You can see where your structure of your system is by just playing with sizes of data and moving them. So embedded systems is an odd subject in the fact that it really encompasses all the other subjects into it. There's a little bit of electronics, there's a little bit of software, there's a little bit of robotics, there's a little bit of physics, there's a little bit of all sorts of things. But embedded systems is really that interface between hardware and software. It's that close connection between those two subjects together. It's really, embedded systems is the name of the subject, but really we could replace embedded with unique systems. So it's the devices that uniquely have to solve problems. So anything from, when you open your fridge door, there's an embedded system that controls whether the light goes on or the temperature of your fridge. And that's a pretty basic, simple system to the embedded systems used to land, the SpaceX rockets, right? Those are much more sophisticated systems. So they vary. They very much are the sort of unique pieces in the hardware world. They sort of solve unique problems. Anyway, so we go down this long list. And it turned out that he said, well, we're from JPL and you're on the short list to possibly go to Pluto. And it'll take us 10 years to get there. So if something goes wrong, we need someone to be able to help us if there's something wrong with the technology. And so that's why they were asking all these questions. But it raises an interesting point that, embedded systems are designed there to last, right? It's not just for, just for the product you release. You have to plan maybe 5, 10, 15 years out. I've worked in the embedded field for probably nearly 30 years, and it's changed a lot. I mean, when I first started, it was a very, very hard area just to make a little LED light flash on and off. Nowadays, I'm holding a device which has 4 processors and runs Linux and can interface with the outside world and is a lot easier to interface with. This is a Raspberry Pi, and it has quite an unusual name, but it is a very, very powerful machine, and it has an interface of a set of pins that you can attach various electronics to. And also you can attach a camera, you can put Ethernet, it's got Wi-Fi, it's got USB. You can do all sorts of really interesting things, and it can support 2 4K screens as well. So really quite a powerful piece of technology. And it, if I look at the mid-range, it comes at around $60 for that technology. And if I go back in time 30 years ago, this would cost, literally $4,000, $8,000 to get this type of technology, and not even at this quality level. I sort of divided the class because it's such a big subject. I could go everywhere. I debate whether we should talk about communication, but that would take 10 weeks to talk about all the communication systems. So basically I divided the class into 2 parts. One is a sort of theoretical part where we talk about hardware and memory and caches and how all the different types of hardware you can find in embedded systems. And we talk about sort of the tools, the software, safety critical, power management, all the sort of hard sort of subjects that are related to embedded systems. And that's the sort of theoretical side. And then on the practical side, I get the students are allowed to go and explore one board. So this is the Raspberry Pi. They go and explore it, and they basically try and take it apart, find out what it has. And you could spend a lifetime discovering what's all on here. This may seem a small board, but to really understand it, probably take a lifetime of knowledge to actually really understand it. So we're going to be doing what is called characterization, which is, we'll take a board and we'll take it apart, right? We'll understand exactly what's on it. We'll understand its limitations, all of these types of things. The students get to pick their own subject, their own interest, and try and build something using the Raspberry Pi with their own interest. So, if you're interested in machine learning, then you can put machine learning on an embedded system and see where that goes. If you're interested in control theory, then you can put some control system on there. Or if you're interested in a musical instrument, a digital musical instrument. I've had a number of people build musical instruments out of the Raspberry Pi. So really, the project is yours to explore, but the exciting bit is that you basically take a bit of the theory, take a bit of the practical side, and try and build something. And at the end of the course, I sit and listen to 30 to 40 different projects that I wasn't expecting, and it's about imagination as well as engineering. In this environment, you don't have to be safe, right? We're not doing the projects to go to a product. We're not in an industry. We're in a university, right? So you can play with things, right? The class starts with just an introduction of embedded systems, and embedded systems really, as I said, is the interface between hardware and software, but it's also the interface to the real physical world. Embedded systems tend to censor the world and change the world. So there's sensors on one side and there's actuators on the other. The actuators cause change. They move a car. They control a beam. They do all of these types of things. So there's two parts of that. So I start with an introduction, try and explain how big the subject is of embedded systems, and then I move on to the hardware and explain in details how the hardware works. And then I explain some of the software, and then I go and explain, we explore really rather than explain power management and all of these pieces. I love speech output systems, and you can do some really clever stuff with Google. And it's worth having a go with it. There's a really clever way of writing a script, sending it up to Google. Google sends back an audio file, and you just play it, and it's just like someone talking in the room. I mean, you can get it to talk, a book, and it's just amazing. But if you add embedded systems into that, you can do some really clever stuff. And one student did a device for the blind, and basically he put a camera on the Raspberry Pi, and as it went round, if it identified a word or something written, it would speak that word as you pushed around the camera, right? So if it had exit, it would say there's an exit. So I think the embedded systems is in an interesting phase, because I think it's all about the programming languages, and if I think the world will go to easier programming languages to allow these more sophisticated systems to be put together. When I'm looking at code for this course, it's not writing lots of code. It's writing a little code that does it right and does it correctly. There's another part of the course which I didn't say. I also follow what happens that week in embedded systems. So I try and explain, what the new pieces are. And sometimes it's boring. Some years there are very few things happening. But in other years, it's a really exciting event. There's lots of things happening simultaneously. And so I try and keep very, very current. in embedded systems, it's very much at the edge of technology, and it's very much at the edge of low-cost technology as well. So the costs are coming down. You know, what we can do today was incredibly expensive 10 years ago. You know, so we can do some amazing things with these small devices. This is a hologram telephone. So basically, there's a device that sort of puts you into sort of digital pieces, and you have a hologram. So you're actually talking to a hologram rather than just a Zoom call or something like that. So and those I've seen improve. You know, I first saw one of these in real life. You know, working at an Intel conference where the computation required to achieve this was colossal, right? And now you're starting to see the technology is sort of catching up, and we're being able to do that, right? So that was interesting. So what do I like about teaching at PMP? So one is they're in a different phase of their careers, as some of them, and they come from very different backgrounds. I've had people who are physicists, I've had people who are electrical engineers, I've had computer scientists, I've had a lawyer, I remember, had an artist actually on the course who decided he wanted to build a much more artistic set of ideas around the embedded systems. And so, you know, that's the exciting bit. I mean, there's a whole load of people with very, very different backgrounds and very different interests. And so I've always loved that.